Welcome to the IT Fundamentals Training Series. This is Mark Haupt, your host, and today we're going to talk about some very important basic functions of the operating system. If there has ever been a segment to pay attention to, this is it. Let's roll with it. All right, welcome back to IT Fundamentals Training Series. This is Mark Haupt, your host, and if there's ever been anything to pay attention to, this is the opportunity to do so, because these things will be on your exam when we're talking about basic functions of an operating system, and they are things that you need to understand. They are all very clearly defined in the book on page 180 and 181. We are not going to go beyond into 182 today. So we're just simply looking at 180 and 181 in the book. So basic functions of an operating system is designed, this segment is designed to show us how the operating system interacts with the other pieces of the hardware, with the computer, as well as different applications and other pieces of software. Probably the thing at the top of the list that confuses people more than anything is the item called the kernel, and that's spelled Kernel. All right, the kernel is a computer program that's inside of a computer program, so inside of the operating system, basically. So it's a piece of the operating system that is absolutely required in order for the rest of the operating system to run and operate correctly. Okay, it is the command and control function, if you will, inside of the operating system. So if you were to look at a diagram, for example, the kernel acts as the interface between the CPU and the applications, or the memory or other types of devices and the application. It is that interface that controls all of those hardware resources, including memory and cryptography, and it's frequently discussed in relation to device drivers, because what happens is the basic operating system has a kernel that's in it, and the device drivers, they provide the attributes and the other functions that are necessary for that kernel to operate effectively with the device, with the CPU, with the memory. So if you can think of it this way, all right, a computer will boot up, and it will natively understand how to talk to the CPU. Then the operating system comes on board, and it starts talking and says, okay, I'm going to use the native communication. But if the CPU has a device driver that's built into the operating system, then it can more efficiently talk back and forth, if you will, to the operating system, and interact with the applications in a more efficient way. Okay, that's the purpose of the kernel. So the book states that the kernel is the central part of the operating system. It controls all actions of the operating system, including the input and the output, which processes get to use the CPU and memory, and translating between hardware and software components on the computer. So you can think of the kernel in one way as a gate guard that prevents an application from overutilizing a CPU or overutilizing the memory. You can also look at it from that gate guard perspective. You can also look at it as the gate guard will validate all of the credentials, if you will, before you go into a gated community, into a military base or something along those lines from the outside. And that's essentially what the kernel is doing. And then that kernel or that gate guard is also directing the person or the function that's coming in from the outside, like the application, into how to properly operate against the CPU. Another example, non-computer wise, is if you go before the king or the queen of England or any other type of function, or even if you go to visit the president of the United States, very frequently those individuals will have an aide that's there that greets you as the prospective person that's meeting the president or the king or the queen prior to you actually meeting. Now, my personal experience, I got to meet a couple of individuals in the White House, one of them being the president, and this aide approached me a number of steps away from the president, and that aide said, okay, I need to know your name, how to pronounce your name, and then what you do as a job, and so on and so forth. So I told the aide, my name is Mark Haupt. I pronounce it Houpt, like house and PT together. Then the aide pronounced that back to me to make sure that he understood and got it correctly. Then I told him, at that time I was in the Navy, and I said, I am a United States Navy cryptographer. And so he pronounced that back to me to make sure that he got that right. And I told him where I was stationed and where I was originally from in the United States. He then turned around and approached the president and said, Mr. President, I would like to introduce you to Mark Haupt. He is a United States Navy cryptographer. He's from Indiana, and he is stationed at the Naval Security Group activity here in Washington, D.C., or actually the Naval Security Station here in Washington, D.C. So he acted as that colonel between the president and I. And then the president and I, once we understood, and of course, he introduced the president to me, he said, Mr. Haupt, this is the president of the United States, William Jefferson Clinton. And so from there on, we reached out our hands, we shook one another's hands, and then we began our very brief conversation there. So we interacted. So in that scenario, the colonel was the aide, I was the application, and the president was the CPU or the memory or whatever you want to look at it. And the aide acted as that interface, and the aide remained there with us to even tell us when I had spent, or the president had spent, too much time with me and I needed to move on to the next individual. And the next individual was the vice president of the United States, Al Gore. And we went through the same process there, only the aide stayed with me, so we didn't have to have the interaction again. The aide stayed with me and he introduced me and said, Mr. Vice President, this is Mark Haupt. He is a United States Navy cryptographer from the state of Indiana and is currently stationed Naval Security Station here in Washington, D.C. And again, then we interfaced, and myself and the vice president interfaced. And then once that conversation was complete, then the aide ushered me out, ended the process, and then he went back and became that colonel again with another individual. And there were multiple aides there, so that the entire process wasn't waiting on me. And that's very similar with the computer, is that with this kernel, the kernel will guide the application into the CPU, guide the application into the memory and the interaction with the devices until that application's done. And then the kernel will be in standby mode, if you will, until the application needs to, or the device needs to be acted again. All right. So that's a long-winded explanation. Hopefully you understood the process there of the kernel. The next item on the list here is version. Now, this is particularly important from a security standpoint because, version is exactly what it is. So you're on Windows 10 or you're on Windows 11. But if you look closer at Windows by clicking on the Windows button and then going to System, you will see that inside that it will list an edition number. So that's Windows 11, and then a version number there. And mine is 22H2, so 22 Hotel 2. Okay, so that is how many patches and how many versions, if you will, inside of Windows 11 exist there. And that's important because that number should change frequently, because actually the OS build version is the one that changes frequently. And my OS build version is 22621.2215. So that version will change whenever I add patches to it to 2216 or 2219 or whatever, even up from that to maybe 23.01 or something along those lines. So the version's important because it will tell you how far back you are on patches, or if you're up to date, and so on and so forth. The item here listed as source. This is source code. So the source code is the base code that starts everything off. It's kind of like version 1 of everything, and then you build on top of that. The book says the actual code that defines a piece of software, or how a piece of software works. So this is also the very basic pieces of Windows operating system, and then other pieces are added onto that. Another item that's listed here is a shell, and the book says a program that runs on top of the operating system and allows the user to issue commands through a set of menus or other interfaces. All right, the shell. So when we're with the operating system of Windows, for example, underneath all that is a bunch of binary, it's a bunch of code that's running. What you see on your screen is the shell, and we'll get to that one next. It's called the GUI, or the graphical user interface. But you could also go into a command line shell if you were to click on your system, your Windows dialog box again, and you were type in CMD or command, you would get what's called a command prompt. And in that, you can then start typing what we call CLI, or command line interface, in order to issue commands into the system. So that is the shell. That's the command prompt shell, or the graphical user interface is the graphical shell that allows you to interact with the source code and the overall code in the system. All right, next one is the graphical user interface. And this one is exactly what it says it is a graphical representation of the code and what is going on behind the scenes. So when you move your mouse across the screen, you're not actually moving a mouse. What that is doing is in computer code, it is issuing a whole bunch of commands that are going through the processor, they're going into the memory, that are actually graphically representing a change on your screen through the mouse pointer. So you're not actually moving a mouse, you're actually issuing code, you're actually issuing directives via code that move the mouse, is what's going on. So the graphical user interface is a graphical representation of what's going on behind the scenes. Cooperative multitasking is when multiple applications are running simultaneously. So right now on my screen, I have multiple installations, or multiple not installations, but multiple windows of Chrome running. I have a command prompt running. I have the settings session running on my Windows side of things. Plus, I have a whole bunch of Microsoft applications. So those are all cooperatively multitasking. And what that means is, instead of just saying multitasking, what they're doing is cooperatively multitasking means that the computer or the software is, when it's in an idle mode, is not utilizing resources that it doesn't need to. So other things that are not in idle mode can then operate functionally. Now you can see this if you were to do Control-Alt-Delete on your computer, and then you were to select Task Manager. What would come up is a whole bunch of showing a whole bunch of things that show all of the applications that are currently running, how much CPU they're utilizing, how much memory they're utilizing, and so on and so forth. Preemptive multitasking is essentially the same thing, but that's where the application is taking some of the resources of the computer preemptively and storing them or holding them off to the side so that it can be ready when it needs to be, and can forcibly take back any of those resources that are necessary. Multi-threading is the ability of a single application to have multiple requests or threads. So we were just talking about different applications multitasking. Multi-threading is whenever the application itself is multitasking within itself. So what we call that is multi-threading. What that does is that it simultaneously sends processing commands down to the processor, and the processor will run them simultaneously and send them back, which means the application ultimately runs faster. So we've talked about 32-bit and 64-bit previously, so I'm going to let you read those on your own. But again, remember that these are the different types of the way the processors are utilized. And if you can, you want to be running in 64-bit mode as much as possible. All right, so these are basic functions of the operating system. They are absolutely important for you to read through and understand. You will get questions on these. Remember what the kernel is, which is why I spent so much time describing that and going outside of the computer system in order to describe how that operates. Keep that one in mind for certain, and then how the multitasking and multi-threading, or threading, is another way to talk about that. So keep those in mind. All right. Again, thank you for joining us on this episode. here is my information to contact me. I again want you to contact me if you have any additional questions, and I look forward to assisting you as we move forward through this process. We'll get back onto this in continuing chapter 4 tomorrow, with how to coordinate users and hardware, providing structure for data management and things along those lines. Talk to you later.